Hi. We'll wait 1 minute, then I'll start. May I know your name? I can't see your name on screen. Hi, Bhavant.
Hi. No one is joined?
Hi, is there? I'll wait 1 more minute, then I'll start.
Okay.
Yeah. Okay, I will start. Welcome everyone. Let me share my screen and quickly go through whatever we have discussed so far. I hope you can see my screen. Can you hear me properly? Yes, no?
Yeah, it's visible.
Okay, fine. So we were discussing about heap and non-heap area JVM, right? JVM, JDK, JRE, how JVM architecture looks like. And I'll quickly go through the recap, whatever we have discussed. So whenever we run a Java program, right, it does not run directly on the operating system, okay? It runs inside a virtual machine called JVM, right? So this diagram shows what happens inside JVM step by step. So Java source code first compiled into .class bytecode. So if you remember the this application that I have shared with you, right? So whenever you run a Java, it gets converted into .class bytecode. So Java does not load everything at once. Okay. So this picture you can see here. Class loader loads required classes into memory only when needed. Okay. I'll give you one analogy here. This is like a librarian. Okay. It brings only the books you ask for. Okay. So if you go to a library, you ask for any book, so librarian will give you that book only. So that's how it works, this class loader. So what it does, it loads classes, verifies bytecode, also links dependencies, initialize static data, all those things. Then comes the JVM area, this area that you can see in the rectangular box here. Okay, so this is the main working area. So after classes are loaded, JVM stores and manages everything in different memory areas, each with a specific job. Okay, so each area has some specific job. The first one, which I mentioned, is a method area. So newer version of Java has metaspace, right? That what we were discussing yesterday. Here currently, that is being replaced using metaspace, right? So this method area in newer Java versions is known as metaspace in modern Java. Okay, so it stores class metadata, it method definitions, static variables, and constant pool. I'll give you one example yesterday. It's like a recipe book, okay, which knows what to do with all the tools available. Okay, so that is how this metaspace is get defined. So it is like a blueprint, right? Now, another thing, the most important for performance engineering purpose is heap, right? So whatever you create objects, so whenever our Java program, so I'll show you quickly one example. So this is how you declare your objects, right? So you have one class, you are creating new object of that class. So all those things get stored inside heap. Okay, all the arrays, instance variables, all objects that you create using new, right? All those are stored in heap. This is the largest memory area, and garbage collector works here in this area, heap area. Okay, so that's what we were discussing yesterday. So garbage, this is the heap, and inside JVM, heap is one of the area where garbage collector works, right? So each now we talk about this stack. Okay, each thread has its own stack. See, heap is the shared area, but when you talk about stack, each thread has its own stack. So you can analyze with this diagram. So in a, see, this is a single thread, right? So, and if you have a multi-thread application, then each thread has its own stack, own registers, own counters, but they have a shared heap. Fine. So that's how heap and stack is differentiated. What it stores? Stack stores methods, your calls, local variables, right? Function parameters, partial results, all those things are stored here. One difference, I'm again reiterating that heap is the shared area, but this is dedicated to each thread. Then comes the PC register. These are program counters. So it stores address of your current instruction being executed. So you can take an example of a bookmarks, right? Let's say you are reading a book and you uh, uh, place one bookmark so that you can come to that page again. So it's like that. Okay. It tells JVM which instruction to run next. Okay. So it tells JVM which instructions I need to run the next. That is a work of PC registers. Then come native method stacks. Okay. These are operating system level native codes. Okay. So whenever Java talks to your native system, it uses a separate stack, which is known as native method stack. Then the execution engine. So it's like a brain, right? Uh, you must have heard of JIT compiler, interpreter. So all this is part of execution engine. Then native method interface. Sometimes Java needs to call more native libraries like operating system features or some hardware drivers. So all those things happens inside here, right? And then finally the native method libraries. So these are external helpers. Okay, so written in native languages. So for our performance engineering purpose, this is the most important thing, heap, right? Memory leaks happen here, GC tuning needs to be done here, right? And if you find any issues or errors related to stacks like stack overflow, that means this area has some issue, right? Any question so far? Okay, so let us move ahead. Uh, till now, we have seen one application, which is a very basic one. This one. Okay, so it got three classes, three API endpoints, a quick one, slow one, and CPU, right? Now, let us see some one level ahead. We are going to design one three-tier architecture application. Okay, so what I mean by three-tier is there will be separate web server, there will be separate database server, and there will be separate application server. You can see, right? So this is my app server start written with, okay. This is my database server. This is a web server. So have you heard about Nginx? But anyway, anyone? Anyone heard about Nginx? Yes, no? Okay, cool. So Nginx means it's like a web server, or it can also act as a load balancer. Okay, so what exact function of this feature is, it routes your request. For example, you as an end user, you are hitting some application. Let's say you are opening Gmail. Now, what is happening behind the scenes? There are different layers, right? For example, one of the layer is web server. Now that web server is provided by different companies. Now, Nginx is one of it. Okay. Uh, it can also balance your load. It also works as a routing, uh, works on routing mechanism. Routing means transfers your request further to the application server. So once I hit my application, it goes here, it goes to Nginx, then it goes to application server, then it goes to database server. Okay. So what exactly happening here is, I'll show you. So we are developing these three layers inside Docker Compose. Like I told you earlier, we are going to use Dockerized container. Okay, so that will be a bonus for you, right? Because you will learn Docker commands as well here. So what I am doing, these are my database related settings. Okay, what kind of database I am going to use? I am going to use PostgreSDB. Okay, that will be my username, that is my password, and is fetching that volume of DB from this location. Okay, these are the default ports of Postgres, right? 5432. Now coming to application server. So what kind of application server it will install? So it will go to this library, this location. This means root, right? Inside root directly inside app folder, it will search for what it needs to do. So if you remember in the previous application, we are directly invoking this pom.xml by running that maven command, right? Similarly, by using docker compose.ml file, we are invoking this pom.xml. Okay, what it does, finally, see, eventually same thing is going to happen, right? Here also you can see those Maven references, right? So it will install all those dependencies from the internet, and it will install on my Docker container. Okay, so these are basically instruction. This XML has all those instruction, all those dependencies that I need to run my application. Okay, clear so far? And in previous one, we have given some JVM arguments, right? So inside this application, we are giving those arguments as Java opts, right? Then this web server, right? And I am giving the ports here, which port I'm going to use, right? All those things I am configuring here. Okay. So if what is happening in the background, if you go to my source code, right? This is a payment controller. It has one endpoint, okay, which I'll be invoking from my browser /pay. Similarly, localhost 8080/pay, right? Now, what it is doing, it is running this query in the background. Okay, so whenever I hit /pay from my browser, there is one query going in the background, select ID, amount, all those things, right? How this query is being run? It has connection with this database. Okay. So what is inside my database? I have these three columns, and there are total 15 rows inside my database. And the first column is ID, the second is amount, the third is status. Okay. So in this way, we are now, this is a level one of that three-tier architecture. In upcoming sessions, we are going to make it bit complex to have more scenarios like memory leaks, like thread deadlocks, DB deadlocks. So I'm going step by step. Currently, this application has only one single endpoint and the database has total 15 rows inside it. Now what will happen? Let me show you how to start it. Let me first to run this as a prerequisite, you need Docker desktop. Okay, you need this application on your laptop. So I can share this code. You can play around with it. Okay, what is the prerequisite? You need this Docker desktop so that you can install all those containers. Right. So currently that application was running. So I just shut it down. So I'll now start it again. So this is my, again, you need to make sure you are inside the same location, right? Currently I'm inside perf demo, and inside perf demo, if you see, so this is, yeah. So when I run that Docker uh, command, it will actually run this YAML file. Okay. So that is how deployment is being done. Okay. When you talk about CI/CD and all those things, how developers deploy their code. So that is how they do. Okay. Any questions so far? Is it clear? Am I making sense? Or I'm going too fast or too slow? Anyone? Okay, so we are going to build this application now. This is the command to start it. Okay, so I'll just run it. Okay, so you can see these three containers are now started. Okay, how to check this? You can run this command docker ps minus a. Right. So when you run this, you can find all those container IDs, right? Application, this is my application server, right? This is my web server. This is the first layer. Web server is my first layer. This is the application server. And the third one is the database server. Database is Postgres type. I hope you are aware Postgres, right? Like Oracle, MySQL. Postgres is also a kind of database, right? Now you can also verify all those things here, right? So you can find inside one package, you can find these three containers running. Okay. Now one thing, yesterday what we have done in Visual VM, if you remember the process ID which was shown here, that was available in my task manager, right? But in this case, okay, let me reload it because I have restarted it. Okay, this is PID 7, right? Now this process ID is not available on my local laptop. It is inside that container. Okay, so if you go to that container and if you click on this, you will find this process ID, right? Is it fine, everyone? Hello.
Yeah.
Yeah.
Okay. So that is how we will deploy this application on Docker. Now, if you run this localhost 8080, localhost 8080 PID 1, right? So yeah, like I mentioned, in the backend, there is one select query running, which will give you the result ID equal to 1, amount is this, status is this, right? Now there are total 15 rows. So till 15 you can run it, right? What are you expecting if you run 16, right? It will give you this error. The application has no explicit mapping, right? So you can run from ID 1 to ID 15. All those rows are present there in my database. Fine. Now, one thing I told you. yesterday. Currently, whatever we did those dumps on the UI, right? How to take dump, you click on this button, you can take the dump, right? How to take dump using command lines. That is also one of the thing we should be aware of, because sometimes you don't have any license tools or even any APM tools, right? But still you want to analyze your application, correct? How you can do that? Let us learn that. Now, the best part is, again, I'm saying this is a bonus for you because now all these containers are a Linux boxes. Okay. And anyone know how to get inside any of this container now? Okay. I'll quickly go inside it. Have you used these commands? Anyone?
I used it for Kubernetes.
Okay, good. So I want to go inside my application server now. So what I will do, this is the command docker execute and then the container name and bash, correct? So once I'll go inside it, so now I am inside my Linux box, which is actually the application server, right? So if you want to see anything, for example, if you are aware of this VM command, right, you can run it, you can see free. I'm going to teach you this as well, what exactly all these terms means, but I'm just telling you. So we are inside one Linux box now, right? Now what I want to do, I want to take a heap dump by using command line, right? So anyone knows the command JCMD? Okay, before that, let us see one thing. What is the Java version here? Okay, so currently you can see Java 17 is there, but this is a JRE. Okay, now let us try to run my command for taking those heap dumps, right? So I'll quickly copy this. I'll just replace this with my process ID. Sorry. Okay. JCMD process ID is, anyone knows what was the process ID? So to check the process ID, you can run this command ps minus ef, right? So you can see Java process is running at process ID 7, right? Are you with me, guys?
Yes.
Okay. JCMD process ID is 7. Any name you want to give, for example, GC heapdump, and where do you want to store? Temporary folder. Okay. Dump.hprof. Now, what it is the command not found. Can anyone tell me why is it so? We have discussed this concept yesterday. Anyone? Okay, this is because JDK is not there. JDK is development kit. Currently, JRE is there, actions, but there is no tool, right? So there are examples of JDK, JVM, JRE as a kitchen, right? So kitchen with shell, chef plus stove, right? Kitchen without chef, correct? So currently, you can run your application, you can run your Java application with JRE, but there are no tools available, right? So JCMD is one of the tool provided by Java. So that is not there. So what I'll do, I'll quickly install those two things. I'll copy this, right? Okay, now it will install that. So now to install this also, there are various, I mean, depending upon the Linux version, whether it is Ubuntu or anything else, you need to find out which command to install. So for me, it is an Ubuntu. So that is why I am using apt. Okay. Now, while it is getting installed, let us cover one more topic. If you remember, in the very first slides, I show you during performance engineering lifecycle, workload modeling is one of the most important thing, right? If you are not testing your application with the desired load, your results may be invalid, correct? So now you have some application, you have a three-tier application with you, and you want to test it s- with some load, but how to decide it? Okay, how to decide what load you want to hit your system? Anyone? How you decide this criteria? What is the criteria for you to decide? So now, so see, let me repeat my question. You have one application ready with you, right? Now you want to test it, right? But I am asking, how will you decide what load you will put on your application? There should be some criteria, right? Okay. See, there is no substitute of production logs. Okay, one thing. If your application is already there in the production, if it is a legacy application, right? So there is no substitute. If you can get the production stats, that will be the best thing to understand what load you want to put on your system, right? Now I'll give you some examples how to figure that out. Let's say you want to test some functionality. Let's say in my inbox, okay, I want to test this compose button. Let me close this. Let me click on this compose button, right? So I want to test, let's say client reaches to you and they say, I want to test this button. So what first question you should ask, how many hits per hour, per second, per day, any data, any stats you have, right? And if you have access to production log, if they have access to production log, you can ask very specific questions. Okay, so in the URL you can see, right, when I click on this compose button, there is new entity get created here. Okay, new parameter get created here, which is compose. Let us take an example of some other application, very simple one, Jpet store. Okay, now you want to test this application and client says how many clicks on this particular button, reptiles, right? So whenever you click on reptiles, there are some requests going on with this username and password with these parameters behind the scenes, right? Now what to do? If there are production logs, if there is an APM tool, it is very easy. I'll show you how. So can you see this or shall I zoom it? Zoom. Okay, let me. Can you see this? What is written there? This query, can you see? Anyone? Yes, no?
Yes.
Yeah.
Okay. So what is happening? See, this is the New Relic logs. This is the real production log. Okay. So I have commented something for security reasons. What I'm doing here is these are 1 day data. Okay, this is the New Relic query language. So every tool has its own query language. Like I was telling about Grafana. If you are integrated Grafana with Prometheus, then you will use Prometheus query language, right? If you are integrated Grafana with InfluxDB, then you will use InfluxDB query language. So this is New Relic query language. These stats are from New Relic. So you can see what happened in last 2 months. Okay. So this pattern you can see, right? So this may be Saturday, Sunday, this may be Monday to Friday, whatever it is. So there is some pattern going on. And where is the peak? Can you see these dates? right? This is 15th October, 15th or 16th October, and this is 30th October, right? So peak is at 30th of October, right? What is the total count? Now what I am doing, okay, so in my query, what I am doing, uh, if you can see here, this is something started with prod. So that is how different environments are differentiated. Every environment has some entity name tag. Okay, so in my case, it was PRD. For perf environment, it is PERF. For UAT, it is UAT, right? So, and then what kind of request you are, right? I mean, this thing that I was showing you here, right? This thing. So whenever you click on this, there is some call going behind, and all these things are getting logged inside the APM tools. Okay, some user has click on this button at what time, right? How many users? So all those things are getting logged inside the APM. So I I was supposed to test one scenario where I want to check how many clicks on one particular feature, and that feature name was ending with .jsp. So that was something like summary.jsp, right? So I was using that, and I was taking the whole count for last 2 months. So when I get the peak, I get the peak on 30th of October. Now this is 1 day data. Can anyone suggest me what should be my next step? Now I get the data from last 2 months. I get a peak on one of the very particular day, and that peak was around 7.5 thousand or 8,000. Let us take 8,000. I hope you can see these numbers on the left,
Yes.
right? So this is 8,000. So what should be my next step? Suppose you have the APM tool, you also did this, you got some production log for any feature of an or any functionality, right? What will be your next step?
Hourly basis on that particular peak dates.
Yes, right. Hourly basis. Now, I did the same thing. Okay. I took those 30th of October data. Now I had the hourly basis, right? Now I found this particular hour has around 2.8K, right? Or 3K, whatever it is, right? So I'll what will be my next step now? I got this hourly basis data now. What will be my next step? Anyone? See, okay, one thing. Can you also think there could be some probability if I take data of hourly basis for this date, let's say 15th of October, it could have given me more I mean more numbers than this and less numbers for other hours. Are you getting my point? So I want to say is it may be one of the possibility that peak hourly basis data for this particular day can show me higher range, isn't it? What do you think? Am I confusing you or am I making sense?
No, basically you're saying this particular date might have the peak load only at 11 o'clock. Maybe other date might have at 10 o'clock or 2 o'clock. Maybe with the same
That's
load
right.
or with different load.
Correct. And that peak may be more than this,
Yes.
right? So what should be your approach to decide your numbers for performance test?
We'll just
See,
check
one
for
thing.
other dates also, right?
So yeah, that is one thing you will check for other dates, but that again, see, performance testing always gives you extrapolatory results, right? I mean,
Hmm.
you need to extrapolate them. It may not give you the exact response time. It may not give you the exact output, right? But those numbers are extrapolatory in nature. You understand it, right?
Yeah.
So one of the approach you can follow is whatever peak you get. Okay, whatever peak you get, run your test 1.5 times or 2 times more than that. Now that will give you more confidence. Okay, now at least I am covering my peak. Okay, and in fact, I am putting more load, right? So the idea is always have more buffer. Okay, whatever you get, right? Always add some buffer on it and run your tests. Got my point, right?
Yeah, basically we add 20% of buffer to the existing load, right? I mean,
Yes.
it can be 20% or 10% on year
Yeah.
increments and all.
Correct. Correct. Now, you have these numbers with you. Now let us do some mathematical calculations. Now you get it. I hope you all have heard of this formula Little's law.
Yeah.
Yeah.
Yeah. Okay. So by theory, it means concurrent users are equal to transactions per second multiplied by time. Now that time includes your response time plus pacing plus think time. I hope everyone knows the difference between pacing and think time. Yes,
Yeah.
no?
Yes.
Okay. So basically, this is a formula to deduce your number of concurrent users, right? And in this case, there are two variables. This one pacing and right, which you can modify, right? Which you can play around, which you can change as per our requirement. Now, coming to this example, let's say you want to achieve 3,000 transactions in 1 hour. Okay, so the TPS will be 3,000 divided by 3600. Correct? Now let's say you run this test and you figure it out. What is the response time for one iteration? Okay, so for my one iteration, let's say it took, I'm just giving some hypothetical numbers. It took, let's say it took 5 seconds. Okay, 4.9. So it is 5 seconds. That was the maximum, but just for example purpose, right? So response time is 5 seconds. Pacing I need to give. Okay, and think time also I need to give. Okay, now there could be two approaches. Okay, suppose in first scenarios you have been not given the user count. Okay, business is not aware about the exact users, but they were aware about the throughput. So this was the throughput, this was the total hits that was happening in 1 hour, right? You need to decide how much users you want to test with. Okay, so there will be two, two things here. The first is, if you put more pacing and think time, so that means you need to put more users, right? So pacing and think time means wait time, correct? So these two are wait times. So if wait time is more, your users will be more. Getting my point? Wait time is more means you need to hit with more users,
Yeah.
correct? Now, other
Yes.
thing is, yeah, other thing is you are hitting frequently. Frequently means you reduce your wait time and you reduce your users. In both the cases, the final outcome will remain the same. In both the cases, let us calculate it like this. Let us take some example here of pacing and think time. Okay, so I did with 200 and 100. So let us, you are running it with 200 users. Okay, now with 200 users, how much pacing and think time you will get? So 200 will get multiplied by 3600 and this whole equation will get divided by 3000. Correct? Anybody good in maths? or I open calculator. Okay. So that will be 720,000 and divide by 3000. 240 seconds, right? 240 seconds will include my 5 seconds of response time. Okay. So 240 minus 5 will be my think time plus spacing. Correct? Okay. So in this way, I am introducing a wait of 235 seconds. This will be my total wait time, which includes think time plus spacing. So 230 minutes means around 4 minutes, right? Around 4 minutes of wait time I have to introduce. That means if I'm running my application, okay, I need to give here how much? 240 seconds, right? Are you with me? Or 235 to be very precise, right? So that means if I hit this API, I will wait for 4 minutes, then I will again hit. Okay, so similar thing will be done by 200 user. They will be doing the same thing. They will hit, they'll wait for 4 minutes, they'll again hit, right? So same thing will be done for 1 hour. Final output will remain same. I'll achieve 3000 transactions, right? Now let us try to test with 100 users. So if I test with 100 users, what will happen? My wait time will get reduced, correct?
Yes, wait time will be
Right?
reduced.
Yeah, it will be almost halved, right? Approximately halved. So this will be my wait time. 120 second will be my wait time. Now I need not to wait for this much time for 4 minutes. I can wait for 2 minutes, 120 seconds, and I can run test with my instead of 200 user, I can run the test with 100 user, right? So what do you think? What should be your approach? Which is the better approach? So see, don't think one is good or I mean one is correct or one is incorrect. What should be your approach? Can you tell me? I mean, how you will take this scenario? So in one scenario, you can test your application with 200 user. The final outcome will remain the same. Okay, you are going to hit that API 3000 times, but the wait time will be 4 minutes. In the second scenario, you are hitting with less users, wait time is also less. So which is preferable according to you? Hitting with more user with more wait time or hitting with less user with less wait time? This is one of the important concept in performance engineering if you do workload modeling, right? Any approach. See, don't think your answer may be correct or incorrect.
Yeah, I will go with the second approach because, yeah, second approach.
Okay. Okay. Anyone else? Okay, fine. So second approach is better according to you, and the reason is
Basically, I mean, yeah, I don't remember now. Yeah, because we'll have the hits. I mean, the user load will be very less uh, on the
Mhm.
application. We will not open so many connections.
Okay, so that is one thing. Okay, so many connections are not there. Okay. See, in this case, I'll also prefer this. If you ask me, I'll also prefer this. In this case, your server will remain busy for most of the time, right? Your application will remain busy. It will remain doing some of the task most of the time. right? But in this case, users will be sitting idle for most of the time. Okay, right? So that is why I mean, I also recommend this approach. Okay. Any questions so far? I hope it is helpful. Okay. So coming back to that application that we were working upon. Okay. So it has given me some error, unable to fetch some archives is missing. That's fine. Okay, let me try this again. Still it is not found. Failed to fetch. Connecting to archive. Okay, let me try it again. Any question on this, guys? What we have discussed so far?
Nothing.
Okay. So coming to this three-tier architecture, okay. Like I have mentioned, these three are the different layers: engines, application, and database. Okay. Now let us run one small test and see how it behaves. The best part is, since we are owning this, you can change anything. I mean, if you want to test it, have you heard about these term connection pools, DB connections? So all these settings are being done inside your resources of application servers. Okay, can you see this? Even in your actual projects, in your actual applications, you will find all these configuration settings here. Okay, so I'll share you this code. You can play around with this. Okay, so there are some default settings that is like max threads 50, spare threads 10. Okay, and what connection pools with database. So these are the total number of connections my application server can have with database. So currently it is 5, right? So you can test how it will behave if you run the load test with 50 user with 5 connections and with 50 user with 10 connections, right? How, what will be the changes you observe, right? So all those things we can see here. Any question on this? Is it I hope it is fine to understand this this application architecture which I'm showing you, or is it overwhelming? Anyone?
I think we need some more basic points.
Like, yeah, basic points. Okay. Yeah, see, so you want to understand each thing, right? How this is built, what is happening, right?
Yeah,
That's what you are saying?
yeah, yeah.
Or you are saying you want to take some, okay. Yeah, don't worry. See, I will explain you each and every line that is being written here. Okay, don't worry. And it will be very helpful because see, in actual real world thing as well, if you are aware of these things, you can, uh, find out issues very efficiently. Okay, so that is where engineering comes into picture. Otherwise, our sole purpose will be just to run the test. So don't worry, I'll show you from each step, okay, what it does, how you are going to uh, run it. I want to give you a high level idea of it today, okay, just to have a feel of it, what we are going to play around. In upcoming sessions, we will go with step by step. Now, this is just one API. Okay. This has just one endpoint here, payment controller. So once you are well versed with it, what we will do, we will introduce some more endpoints. Okay, so that's where Java concepts also comes into picture. We'll have some static variables. We'll create some more endpoints, do some more work, create some memory leaks, create some deadlocks, right? All those things. So I'll teach you each and everything step by step. Don't worry. Here, as of now, anything, I mean, when you say basic things, so what do you want to understand here as of now, whatever I have shown you? Hello? Okay, so see how we are deploying this application. This is the main file that is responsible. Okay, so when I run this command, right, docker compose build, so what it does, it start reading this YAML file. Whatever inside this my is there in my YAML file, it start reading that. Okay, so now you can see there are three tags here. The one is DB, another is app, another is Nginx. Okay, now what it does, it will let's say this tag app, it will go inside the root folder and in application folder. Okay, here, right? And the earlier application, what it does, it read the POM and install everything, right? So similarly, you are just installing all those things using your Maven, okay, here. Okay, so it will basically see, to have your application running, you need some files, right? Some libraries, correct? So that you can
Yes.
make connections with application and database. So all those things are taken care by this pom.xml. Okay. Since
Okay.
see to in yeah, nowadays everything is being done using these commands. Okay, so earlier, if you remember, if you have to write a program to connect your JDBC connections, right, you have to run some strings, but all those things now is just a matter of, I mean, one line, correct? And and inside this, this is the main Java class. Okay, this is the main class that we are running. Okay, so see, this is the JDBC connections we are making with database. Okay, and see hash map, right, with this query. Okay, so whenever you run this endpoint, you are actually making a call to a database with this, right? With this JDBC connection, you are making a call to a database, and inside database, there are 15 rows. Okay. So when I run, okay, let's go step by step. When I run docker compose command from my PowerShell, it read all those things from YAML file. So whatever it is written there in each, for example, it goes to DB folder. It goes to this folder. It will create an image called Postgres 15, and all those things are, you can also make any name you want. All those things are configurable. Okay, it is downloading this volume, and by default ports of Postgres DB is 5432. Okay, and it is doing some health check every 5 seconds. Okay, this is inside the database, the content of the database. Okay. But don't worry, I'll teach you each and every file how it works. I want to give you a feel of it, okay? So that it will not be something new in upcoming sessions for you. Okay, so it is still being installed. Okay, fine. Now that JDK has been installed. So if I run this command now, right, you will find open JDK this time, correct? Now if I run JCMD, process ID is 7, GC heap, whatever you want to give that name. I want to store this in temp folder, okay? And heap dump underscore 6th Feb dot hprof. Okay, it's showing 711 diagnostic command. Wait a minute.
We didn't give
I,
time also, right?
sorry,
We didn't give time also, right? How much time to record?
how much time for this dump you mean?
Yeah, yeah.
Okay. See, dump means a snapshot. Okay. So whenever I take a snapshot, it will take snapshot for that particular time. I think my this name, yeah, this was the illegal exception here.
Yeah.
Yeah. Now it is started. So now dump has been taken and it is stored here. So you need not to give that time frame, okay? Because dump is like a snapshot. It's like you are clicking a picture. Okay. Now if I go to ls means list, right? And if want to cd means check directory, I am going to temp folder now. So this is the temp folder. And if I run this command, so you can see the heap dump has been taken, right? Now you want to take this heap dump on your local so that you can read it, right? So similarly, you can copy this by using docker cp, then the container name. This is my, sorry, container ID. This is the container ID. Okay. Name can be, similar, but container ID will always remain unique. Container ID colon the folder. So it is inside folder. Okay. And I'll store here only in my local terms one. Okay. So it has stored it on my this folder of demo dumps one, right? So this is the heap dump. Now you can just open this, right? You can go load dumps one, right? So this is how you can take heap dumps using commands. So if you don't have any UI tool to take a heap dump, you can still use JCMD commands. I hope now you see the difference between JRE and JDK, right? If I don't have JDK, I do not use those tools, right? I can still run Java program, but I cannot run those tools, right? Any questions so far?
No.
Okay, so in upcoming sessions, we will first check about threads, process, and programs, right? Because in later part, we will also learn thread dumps. So before learning thread dumps, we will we will see what exactly thread is and how it is different from a process and how process is different from a program, right? So I mean, are you all available on tomorrow on this weekend? Can we continue these sessions on this weekend, Saturday, Sunday, or you want to have this on Monday?
Can we start by Monday?
Okay, fine, no issues. Okay, have a great night and let me know if you want if you have any questions, and I'll be sharing this application. You can play around with it. Yeah,
Yeah, sure. And please go with a
and
very basic. Maybe if we know the basic, we can understand the next level easily.
right, correct. So can you tell me like what kind of things you didn't understood today's session? What was some, I mean, where I can
No,
make some
like
changes?
go with a step by step, like a server. Once you finish the server, next is thread or process, like that. CPU, memory, disk, that knowledge. After that, you can explain that the whole structure.
Okay. Okay, fine. We'll go by that then. But I think this is a part of server only, whatever I am showing you. Anyways, I'll try to make it more basic and so that you can easily grab it. Yep.
Yeah.
Okay, guys.
But
Let's
once
catch up
we
on
strong in
Monday.
a basic, we can easily learn that advanced level.
Right, correct. May I ask one question? Are you doing performance testing, or what kind
Yeah.
of expertise you have? Okay. So what are you actually doing in your projects currently?
Currently, I'm using Jmeter.
Mm-hmm.
Most of the
Okay.
time, we just use the HTTP protocol, the simple protocol.
Okay. Fine. We'll yeah, we'll go by like that only. Don't worry. Yeah. Anything
Yeah.
from anyone? Anything else?
Nothing from my side.
Okay, fine. Then we'll catch up on Monday then. Bye bye.
Yeah. Thank you.
Okay. Thank you.